Given that a complex number z is b plus I squared, where b is real and positive, find the exact value of b when argument z is 60 degrees. Let's consider what is argument of a complex number and when it's 60 degrees, what does it mean? When a complex number is in the Cartesian form x plus iy, it can be represented on the organ diagram. X-axis is the real part, y-axis is the imaginary part, and 60 degrees here it's always 0, and 60 degrees it's in anti-clockwise direction. So argument of z is 60. A complex number is somewhere here where x coordinate is the real part and y coordinate is the imaginary part. So idea is the next. If we represent a given complex number in the form x plus iy, hence we can relate x and y using, for example, tangent of 60, and hence we can solve for b. So let's consider given complex number, and let's just open the parentheses and get that it becomes b squared plus 2bi plus I squared. I squared is -1, so it becomes b squared minus 1 plus 2bi, and hence the real part is b squared minus 1 and the imaginary part is 2b. And we can see that if we consider tangent of 60, it is equal to opposite over adjacent, so it becomes 2b over b squared minus 1. Tangent of 60 is √3, and hence we get that b squared minus 1 is 2 over √3b, and we can see that it's a quadratic equation and it can be solved with discriminant. So discriminant is b squared 4 over 3 minus 4ac, so plus 4. It's 4, 1/3 plus 1, which is 4 times 4 over 3. Hence, roots become b is minus b 2 over √3 plus minus root d, which is 4 over √3 over 2a, and it becomes, we can divide each term by 2 and it becomes 1 over √3 plus minus 2 over √3. And since b is positive, it is given that b is real and positive, hence b is 1 over √3 plus 2 over √3, which is 3 over √3, and it's just √3. When minus is here, we can see that it's negative. So there is only one possible value of b, and it's √3. So it's the answer, and that's all for this question.